Hello, everybody, and welcome back to Math 100. This is section 4.3. Now, in the first two sections of probability, chapter 4, we encountered several situations where we had to count the number of possible outcomes and so on. So counting actually plays a major role in calculating probabilities. So section 4.3 is all about counting. All right, so let's get started as I share my screen. All right, the title of section 4.3 is Let's Learn How to Count. Okay, so sounds silly, right? We all know how to count 1, 2, 3. Yeah, the question is to count how many ways we can do certain things or how many ways in which certain things can be done. All right, and we will learn 3 different types of countings, basically. I mean, there are many other variations of them, but essentially there are 3 main types of counting. Now, there are some formulas, but you don't need to know really any of these formulas if you know how to think and what to think concerning the different ways of counting. All right, so here's the key word here, which is the key word really for this entire course, right? We have been trying to stay away from having to memorize formulas because formulas are things that you can look up, but the way of thinking, I mean, that's an art. And so I want you to, again, wear your thinking cap and try not to memorize procedures and formulas. And so for these reasons, I am actually not going to present certain formulas that you see in the book, but rather I'll show you a way to think and to solve these problems without knowing the formulas. Okay, so the first step or first way of counting is this thing called the multiplication rule. Okay, what in the world is the multiplication rule? Well, when things take place in multiple stages or steps or in a sequence, right? What you have to do is to draw a tree diagram or to use what is called the multiplication rule, because what you have to do is basically to multiply the different choices you have in each stage. So there are 4 examples I have here. Let's say you have at a restaurant, you have 2 choices for the appetizer, 4 choices for the entree, and then 3 choices for the dessert for a 3-meal course. Right? How many options are there altogether? Right? So you have appetizer 1 and appetizer 2, right? And then you have entree, so it's entree 1, 2, 3, 4, and so for each of these choices, you have 3 desserts, right? D1, D2, D3. You can already see that the branches are getting too crowded here. Okay, but the whole idea is that you have 2 possibilities for the appetizer, and for each of these, you have 4 choices for the entree, and now we have 8 choices for the combination of appetizer an appetizer and an entree. Then you have 3 choices for each of those 8 choices, and so all you have to do is to multiply these numbers, and that is how you calculate how many options you have. In this case, it's 8 times 3, and the answer is 24. Okay, now you can draw a tree diagram, but usually, or many times, you can tree graphs or tree diagrams. Many times, these will get too complicated or too many branches, and so sometimes it's not very practical. Okay, the next one here, 5 flights exist from LAX to Chicago, and then you have, so let's say LAX to Chicago. What is the main airport in Chicago? You know this as the O'Hare Airport, and for some strange reason, it is called ORD. That used to be called the Orchard Field. And then to Atlanta. All right, so you have 5 different ways to get from LAX to Chicago, and then 3 from Chicago to Atlanta. if you have to fly from LAX to Chicago and then from there to Atlanta, in total, how many ways are there? And the answer is 5 times 3, which is 15. Okay, so these are pretty simple questions, right? All you have to do is to multiply the options for the various stages. All right, so the next question, how many 7-digit phone numbers are possible? All right, so the phone numbers have the form digit, digit, digit. Many times you use the hyphen. And so this is the case. Now, how many digits do we have? I mean, well, it's a 7-digit phone number, but for each of these, for each box, we can have 10 digits to fill these with, right? So we have digits called 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And altogether, that's not 9 possible numerals, but it's 10 different numerals, okay, if you include 0. So any of these boxes can be filled with any of the 10 possibilities. Do you see why this is counting the multiplication principle? Because for each, you have 10 choices independently, just like here, you know, the choices of the entree was independent of the choice of the appetizer, and choice of the flight to Atlanta was independent of the choice of the way you fly from LAX to Chicago, and so on. So it turns out to be 10 times 10 times 10 times, you know, you basically had 7 tens multiplied together. We write that number as 10 to the 7th, as you know. And so this is 10 million. Now notice here, I do have 10 million possible phone numbers, but in reality, they are not going to allow numbers like 0000000, right? Or 9999999. And so there are some numbers that they exclude. But if all possible choices are, you know, allowed, then you would say you have 10 million choices to choose from. Okay, now here's an interesting one, and that's why I'm not teaching you how to use formulas, because sometimes the formulas cannot address various different, you know, possibilities or different variations. What happens if you are still talking about 4-digit phone numbers, but if the first 3 digits can't be 0, okay? So now you have, and by the way, I recommend that you draw a picture like this, just so that you can visualize what's going on with your question here, right? You have 7-digit phone numbers, so you are filling in these blanks here, but the first 3 digits can't be 0. So here you're only allowed 1 through 9. That's 9 digits, right? For these last 4, you can have 0, so any of the 10 digits will be okay, right? You see the problem here? This time it's going to be the multiplication rule applied, but 999 times 10, 10, 10, 10. Because the first 3 digits, for those digits, you have to exclude the number 0. All right, so this is 9/3 times 10 to the 4th. If you do this in your calculator, you will see that this is 7.29 million. 729,000,000. Okay, and so the answer is 7.29 million phone numbers if the first 3 digits cannot be 0. Okay, so this, I hope this is easy to understand, right? The multiplication rule. Similar to that is this thing called permutations. Okay, what is a permutation? Well, when you have a physical object, okay, there are different ways of arranging and rearranging these objects, right? And the question is, how many arrangements are there? Each arrangement of these objects is called a permutation. And the thing is, if you have a physical object, you can't have the same thing as the first item and the second item, right? Let's say you have 4 books and you're going to pick 2 of them to, you know, let's say you have 4 books to choose from, and you're only going to pick 2, and you're going to put them on the shelf, or make a list of 2 books to read where the order is important, okay? You can pick any of the 4 books for your first book, but once you took that one, See, you can't say, well, I'm going to read this book again. I mean, you could, but in terms of a permutation or ordering, you can't have that book again in the second as a second book. So here you only have 3 possibilities. So every time you multiply, you have to subtract 1 because repetition is not allowed. And that is one key element in permutations. See, in permutations problems, in which you are arranging or listing things in a certain order, okay, repetition is not allowed, and the order matters. The order is relevant, and repetition is not allowed. All right, I have 3 examples here. Suppose you have 5 songs in your device, okay, on your cell phone or on your music player. How many different orders are possible if you want to, rearrange these 5 songs? Okay, again, you can visualize it by just drawing 5 boxes, right? And you have 5 songs to choose from for the first one. And once you choose that one song, how many songs are left to choose from? It's 4, right? And once you choose the first 2 songs, there are only 3 left. And once 3 are chosen, there are only 2 left. And of course, there's only 1 song left at the end, and you have to choose that one as your 5th song. So the answer is, it's really an application of the multiplication rule, right? But when you multiply these numbers in this way, starting with some number, an integer greater than 1, and then you multiply as you subtract 1 each time until you get down to 1. Such a product, the answer to multiplication, is called a factorial. So this is called 5 factorial. Basically, the definition of, I guess I should specify what I mean by factorial. Factorial is denoted with this exclamation mark. I will tell you why in a minute. The exclamation mark. And all this means is you start with this number and you multiply that number minus 1, that number minus 2, and so on until you get down to 1 as the number to multiply. So 5 factorial is 5 times 4 times 3 times 2 times 1. And this turns out to be 120. That's a rather large number, right? I mean, 5 songs is not many songs. But if you want to arrange or order these 5 songs in specific order, there turns out to be 120 orderings you can choose. Okay, all right. Next, sometimes you don't want to use all 5 songs. Maybe you just want to pick 3 songs out of 5 and list those 3 in order. What happens if you have 8 runners and you have to choose first, second, and third place winners? How many different ways can that happen? Okay, now be careful here. I don't have to draw 8 boxes here because all I need is first place, second place, and third place, right? How many choices do I have for the first place? Well, 8. Any of the 8 athletes, runners, can win first place, assuming they, are competent runners. But once you choose that first place winner, the first place winner has reached the goal. There are only 7 to choose from for the second one. Clearly, because the repetition is not allowed, all right? In other words, one person is not going to win first and second place and third place, right? So you can't do that. So repetition is not allowed, and the order is especially important because you are choosing number 1, number 2, and number 3. And then the third, well, after the 2 top runners have reached the goal, there are only 6 to choose from for the third. So the answer is 8 times 7 times 6. This is not 8 factorial because this doesn't go all the way to 1. But this number here is 8 factorial. And that turns out, no, not 8 factorial. 8 times 7 times 6, and that's 336. There are 336 ways in which to choose first, second, and third place winners out of the 10 runners. Okay. Again, this is a little surprising. All right, in a similar way, part C is very similar to part B. This time you have 10 books. You're going to pick 3, and you want to make a reading list, but reading the books in the order ABC is different from BCA, for instance, okay? So we assume that the order does make a difference because we are talking about the arrangement of things. That's the characteristic of permutations problems, all right? So in this case, you are picking 3 books. You have 10 choices for the first, but once you have finished that one book, we are not going to read that book again because we are, making a reading list. And under the assumption that the repetition is not allowed, you have 9 books to choose from for your second, 8 for the third. And so the answer is 10 times 9 times 8, and that's 720. So there are 10 to choose from for the first, and then 9 left to choose from for the second, and so on. And the answer is the product of these 3 numbers, and the answer is 720. So I hope you have seen a pattern here. The order, if the order is important, and if no repetition is allowed, okay, what do you have to do here? Right. I'm going to go ahead and write down what I mean by that. Okay, so there are, in the case of the 10 books, okay, there are 10 to choose from for the first book, right? Maybe I should not repeat what I said here. But anyway, for the part C, you have 720 books. But in all of these questions about permutations, there is something in common, right? That is the numbers in multiplication go down by 1 because you cannot choose what has already been chosen, i.e. no repetition allowed, okay? And so what you have to do is to start with the total number available. Let's say total number. And the number of numbers you're multiplying is the number you pick, right? Right. So multiply as many numbers as you are to pick. So you're, like, for instance, in this case, you're picking 3 books out of 10 in a particular order. And so that means you multiply 10, 9, 8. And now that you have 3 numbers multiplied together, you stop. If you're picking 3 runners in order from 8 runners, you go 8, 7, 6. And because those are 3 numbers multiplied, you stop. And so that's the way to calculate these permutations. Okay, those permutations. Now let's go to the second page, which introduces us to the third of the 3 counting methods, right? We had the generic or general multiplication rule, and we had permutations. The combinations typically is the hardest one to understand and typically the hardest one to teach. So I want you to here, let me get started, and I want you to do a little problem here at the beginning of the second page, right? A combination. What is a combination? A combination is similar to permutations, right? You're picking up objects out of a large set, and like 8 books or 10 books or 8 runners or something. But in this case, we're just picking a certain number of those things, and the order is not important. Right. So for instance, if you were to pick 3 committee members out of 4 candidates, right, you're picking 3 people out of 4. There are 4 people available, you're picking 3. How many ways can you choose the committee of 3 people out of 4? Now, the fact that you can pick ABC or ACB in that order, it doesn't matter, right? Because ABC and ACB and BCA and CBA and all those things are really going to constitute the same committee. So that's the difference, okay? Now, the way to think about combinations is as follows. I want you to think about the possibility if the order were important. If the order were important, and if you have to choose 3 committee members in a particular order out of the 4 candidates, how many ways do you have? okay? And I want you to list all of the possibilities here, right? And once you think you got it, then let's open or let's start your next part of this video and see if you have listed all of the possibilities. Again, try to list all the different ways to list 3 of these names, A, B, C, and D, in a particular order, where the order is important, but you can't repeat the letter. Okay, so you can't have AAA or BCB or anything. You have to pick 3 distinct letters out of these 4 letters in different orders and see how many permutations you have when you have to pick 3 out of 4. All right, so this will end the first segment of the video, and I will answer this in the beginning of the second segment.